Okay, welcome to this video on the 2011 Section B Higher Level Question B2. So the 3D graphic on the right shows an exit from Dublin's Port Tunnel. The outline exit of the exit is also shown as a line diagram in the thought bubble. So here's a similar solution. It's not totally the same. Figure B2, alright, below here, shows an incomplete dimetric projection of the tunnel exit using the axonometric axis method. The elevation and end view are shown in their required positions. Part A. Draw the axonometric axis, X, Y, and Z, and the isosceles triangle A, B, and C. Part B. Draw the elevation and end view orientated as shown. Part C. Draw the completed axonometric projection. Part D, in the pictorial projection, so in this, pictorial is another word for 3D, identify the traces of the simply inclined plane that contains the sloped surface of the exit. Alright, so the sloped surface of the exit. Right now, so it said it's dimetric. Alright, remember your question is the best source of information. The scale is 1:100. Convert all dimensions into millimeters. So 1 meter equals 1,000 millimeters. 14,000 millimeters equals 14,000 millimeters. And we have to divide that into our scale. Alright. So we need to convert all these into millimeters. Right. Dimetric means two of the angles inside the axis are the same. So this one is 115. This one is 115. The y-axis is always vertical. Right now, so I'm going to get going here. Right. So I'm going to draw in my y-axis. Okay, I'm going to keep it down low at the page, alright, as much as possible, alright, because of the fact we're using an elevation and end view. That frees up space. Okay, now I was about to draw a line there. That would have been isometric. It says the angle is 115. Okay, so we're going to pick a point here. Alright, we're going to measure an angle of 115 degrees. So there's our point there at 115. Okay, and then the other side we're going to measure again at 115 degrees. Okay, be careful not to do 105 by accident. Okay, a mistake many students do make. Alright, we're going to draw in our two lines here. Right, now, the question says that it is 14 meters in real life. Convert that into millimeters. It's 14,000. Divide that by scale 1:100, you get 40. So to establish point A, alright, draw a light line horizontally here. Measure the distance of 70 along here. So I got 70 because it's half of 140. Drop a light vertical line down here until it touches the axis, and there's point A. Okay, a light line, alright, horizontal across until it touches the other axis will establish point B. Alright, now the trick is then, how do you establish point C? Alright, and the key information here is that the green line, BC, makes an angle of 90 degrees to the Z-axis. Alright, so here's my Z-axis, here's my X-axis, and there's my Y-axis. So I'm going to extend on my Z-axis or my X-axis, it doesn't make a difference. And I'm going to draw a line at 90 degrees to that. Okay. So this line here is at 90 degrees to the z-axis. So I'm going to extend this on till it hits here, and this is point C up there. And point C joins back to point A. Right now, we're going to set up our two triangles, alright, our two outline triangles. Now, I'm going to move the visualizer over towards the right. Okay, here we go. Right, so we're going to extend, okay, the points C and B. Okay, we're going to draw two lines parallel to the z-axis from C and B. Now, so there I have it. And down here, and I'm going to carry on. I'm going to carry on my, what axis did I call it? The z-axis. Okay, now they can go on for any particular distance you want. Okay, in this question, I'm going to measure out about 120 should do fine. So I'm going to measure 120 out. Now, the green line you're going to see here, this green line is parallel to the green line BC. Okay, so I'm going to draw a line parallel to BC. Over here. Alright, now I need to get the middle of this green line. So in order to get the middle of the green line, alright, to set up the semicircle as shown here, I need to bisect the line. Alright, so to bisect the line, set your compass to a distance of more than halfway and swing from both ends of the line you want to bisect. Okay, it's probably run off me. No, it's not going to run off my desk. So there we go, and then I'm going to draw in a line there that's allowing them to connect. And this point of intersection is the center point of our semicircle. And then we join them together. And now, there's the semicircle. This point here, okay, is found. So this point here is found by extending the z-axis until it intersects there. Okay, and then you can join these up together. Right, and there's the outline of the elevation in its required position. So bearing in mind we're dealing with part B of the question now. So I'm going to go to the other side now and apply the same concept. So the green line here that you're going to see, this one is parallel to AC, and the two green lines, this one and this one, are parallel to the x-axis. So I'm going to line up my set square with the x-axis. And I'm going to draw a line from point C. I want to extend on my x-axis. and I recommend about 110 for this one here. There is no set distance. All right, we go with 120. All right, give ourselves an added space. We'll even manage a bit more. So we'll settle at 130. Final answer. Okay, there's no specific distance you have to go. All right, you just want to have enough room to draw in your view here. All right, now we're going to draw a line parallel to the line AC from that point I just drew in. Okay, and I'll bring up what you get there in a moment, and I'm going to have to just drop this down as the tip of the set square hits the visualizer. Right, so that line there I've just drawn in represents this one here. Okay, now the same strategy again to get the semicircle. Okay, put your compass on the end of the line, set it to a distance of more than halfway. So I'll run out onto the desk there a little bit. And where the arcs crisscross, where they intersect, we're going to join them together. Right, and this is the center point for the circle. Now, a common mistake students do is they put the semicircle out here, all right, out to there, all right, which we want to put, okay, on the inside. So mine's gone a tiny, it's a very marginal amount off. It's not major. Right, now we're going to where the x-axis intersects the semicircle is the point for our triangle, the orientation of the two views. Okay, so we're going to join these together. Now, all right, now it takes some analysis of the question to get the right dimensioning. Okay, I'll zoom in here. So the radius, right, is not given. But if you draw a line up 35 millimeters, parallel to the blue line here, where it intersects, where it intersects this semicircle here, you see, that gets you a radius for that curve. Now, you might be wondering that there, but the radius is it's the distance of the triangle is the outline for the port tunnel. Alright, so that is the outline start. Right, so from there to there is the start. So we need the center point of that. So we're going to do that by bisecting the line. So I set my compass more than halfway. Now, there's the center point for this semicircle. Alright, to get this line, we have to measure up 3.5 centimeters and draw a line parallel to the base. Okay, now I'm going to do that. So I'm going to get my compass here and I'm going to draw in a semicircle. There we go. Right. I'm going to measure up 35. And then I'm going to draw a line parallel to the base here. And then where it intersects represents the 2 points here on the question that I'll bring up in just a moment. So So I'm going to heavy them in. Right, so those two lines represent these two here. Right, that's what they represent. Then we're going to take our compass. Alright, we're going to draw heavy the arc in. Alright, and we've got the end view done. Alright, the next question is doing this here. So from there to there is 3.5, but the question is, what is it from here to there? And the answer is that you move over to your elevation and you take the height from the elevation. So the radius, the end elevation rather, the end view. Alright, so you take the height here, the radius, and you apply it here. And the sloped surface is along that triangle there. Now don't get bogged down on questions having to be touching these points here. They don't always have to. So I'm going to move over to the other side and just let you know that my compass is set to this radius. Alright, so as I move this over to the other side of the sheet, okay, now I'm going to adjust that visualizer. So I'm going to put my compass there, and that gets the top point. The other height is 3.5 centimeters or 35 mil up from the base. So I'm going to mark 35 mil up from the base. Now I'm going to draw two lines parallel to the base of the triangle. Okay, I'm going to heavy one in and then move this one heavy up to there. To there. Alright, then I can heavy in here and heavy in here. Alright, now from there on, what it takes to do this is an understanding of where the points are in the different views. Okay, so I'll just move my visualizer over. Right, there we go. Now, I need to know that this point here, number 1, alright, I'll zoom in here. This point here, number 1, is that point there, and is this point here in our elevation. Number 2, it's here, it's there, and number 2 is also at the same height here. 3, okay, is there, and 3 is here. 4, alright, is there in 3D. 5, okay, is also here. Okay, but it's at the back there. 5, 6 in there, 3/6, so 6, 6/5, alright, 3/4, so this will get us points 3 and 4, alright, and then 5's there, right. I'll slow down and do this on this sheet. Okay, so it's a matter of bringing the points over parallel to their respective axis. So 3/6, 4/5. So that means 4 is closest to you and 5 is furthest away. Okay, I'll zoom out there. Okay, 1, 2. Alright, so 1/2, 3/4, okay, 6/5. Okay. And then we'll go in here 8 and 9. So 8, 9. You know, we won't really need 8 and 9 if we do this. So we're going to take all our points parallel. So these points, we're going to bring them all parallel to the x-axis down towards here. So I'll just zoom in here as we do that. So look, this line is set parallel to the x-axis, alright? Because that line is already drawn parallel to the x-axis. So I'll bring both of my all my points from this view, okay, down parallel to the x-axis. Right, so I have them done. Now what I'm going to do is bring the points from the elevation parallel to the z-axis. And after that, what I'll do is I'll extend any points that need to be extended. I will extend them. So 2 and 1. So we're bringing these down, right? Now, so I'll zoom out here. To figure out the points in 3D, you follow one down here. So you follow one down and you follow one down from this view. And where they intersect equals point 1, alright? Now, for 3, you follow 3 down and you follow 3 down from here. And where they intersect gives you point 3. Okay, same with point 4. So I'm going to follow point 4 down, and I'm going to follow 4 down. And where they intersect equals point 4. The same with point number 2. I'm going to follow point number 2 down. Now, from my view, my projection, it's like a tiny bit off. This is the more appropriate location for it. So I follow 2 down from here and follow 2 down from here to where they intersect. So now, 1 joins the 3 in this view, alright, and 1 joins the 3 in this view. So they're going to join together here. So 1 joins the 3. Okay, same with 2 to 4. 2 joins to 4, and 4 joins to 3. Alright, and 1 does not join to 2 because there's no heavy line in my end elevation joining them together. So there's them together. Now, to get point 6. 6 is followed down here and 6 is followed down here. And there's point 6. So I can heavy that there. Now, point 8, we follow 8 down, follow 8 down here, and there they are there. Now, it should be vertical. And I can see the tad off. So a more accurate way to do is just set your set square parallel to the y-axis and draw it in. It's very, very minuscule. The intersection is a minuscule amount of its respective points. So I just drew it in vertical. Right, now, 1 joins to 8 in this view here, so I'm going to join 1 to 8. Alright, now, I wouldn't do anything else yet. We need to do the curve. Alright, so to do the curve, we need to establish a set of points on the curve. Alright, so what I'm going to get you to do is establish points by going a specified distance up here. So just I'll zoom in here. So I'm going up 5 and 5. And I'm drawing two lines parallel to the base of the triangle in our end elevation, and these are going to establish points for us. Okay, now we need to get them in the other view. So I'm going to take what you call it the height with my compass. So I'm going to take the height there with my compass. So set to there, lift it, put it over here. Now, this one here. Okay, there, that's the altitudes of them. What's important to note is there's going to be a curve at the front and a curve at the back. So the points we established here represent points on the curve at the front and the back at the same time. Alright. Now, I'm going to go over here and I'm going to call this A, B, C, D, E. Right. Have a think now. What do you need to do with these points? Have a think. Alright. And the answer is they all need to be brought down parallel to the x-axis. I'm going to line up my set square and I'm going to bring E down, Okay, I'm going to bring D down, and they're so close to being on the same line. Alright, that's not a problem. I'm going to bring C down. Okay, then I'm going to bring B down. A down. Now, I need to establish their positions exactly over here. I established the altitudes there. So what I'm going to do is bring these points that we'd marked in with our compass parallel to the base over to the sloped entrance. So I'll bring these over here. Now, so this is A slash E. Okay, B slash D and C. Right, now, same idea over from our elevation. We have to bring these points, alright, down parallel to our z-axis. So we'll bring A slash E down parallel to our z-axis. B slash D down parallel to our x-axis, and C down parallel to our x-axis. So where A, okay, intersects point A, we're going to mark in. So A intersects point A is point A, and so on and so forth. B intersects point B. You can always use your set square to help you figure out where they are, because sometimes you can get a bit lost. C, right, C, D, okay. So D, E then, and then 2 there is done. Alright, now let's do the back of the curve. Alright, so I'm going to go over here. The points in the back, we'll give them different names. Alright, C, D, F, G, H, I, J, and then 9 is what you call it, 9 is there. Alright, but we won't need that. Alright, now, over in this view, it's F/J. So F is the first one you see, J is behind it, and the reason it's F and J is F and J are on the same altitude. G/I, and then H. So we're going to do the same idea. We're going to bring these points down. So I brought them down parallel to the z-axis. So I follow F to meet F. So there's point F. Now I'll follow G to meet point G. So there's point G. I follow H to meet point H. And now, after this really, I can't see much more of them, right? So, I'm going to bring D down to, or sorry, not D, I rather, down to meet I. Okay, so there's point I. And after that, I can't see the rest of them. Okay, right. What we do is we freehand sketch these in. So I'm going to pause the video and sketch this part of the curve in. Alright, I'm also going to sketch this portion of the curve in, and I stop sketching at I because I can't see after point I. I can't see. You cannot see the points in the curve underneath the letter I. So if they're inwards, very closely there. Look, I'll zoom in. So like for example, 9 is one you cannot see. It's underneath I. It's inside the object, so I don't draw them in. Alright. I'll pause the video here and do that. So that's what I have there. Now, I'm going to join I to D, heavy, alright, and I'm going to just look in here. I'm going to heavy that line back until it hits the roof. Alright, and I have a heavy line here, so that means I need to have a heavy line from 2 going back inwards until it hits there. Alright, now the next part of the question says, alright, determine the traces of the plane, alright, in the pictorial projection that contain the sloping front surface. Okay, so I'll bring up the question. So, in the pictorial projection, identify the traces of the simply inclined plane that contains the sloped exit. So what that means is show where the plane, okay, this one here, that contains the sloped front, intersects the portion, or the vertical plane and the horizontal plane. Alright, now I'll show you that there. So I'm just turning off views here. Okay, now, so where this line intersects the vertical plane is here, and where it intersects the horizontal plane is down here at the bottom. Alright, so it's simply heavying in this line here. So this is the HT, and this is the VT. This is the VT. And that is so because the front here appears as a point there. Alright, the HT is along there because the front of it is appearing as a point there, and we can bring it back here parallel to the Z axis. Oh, now, what? That is the question done, and you should I'm going to get you what's called an example of what a finished, what sort of notes you should add in.